Many toolkits for building physical computing systems have been developed, but novices starting out in this domain still encounter a range of challenges. In the software learning domain, a number of reactive tutorials have been developed, which can respond to a user's actions, providing error correction and guidance to help them learn. However, these techniques are difficult to extend to the physical computing domain, where tracking a user's actions is more challenging. In this paper, we investigate the idea of test-driven tutorials, which inject interactive tests into physical computing tutorials to verify wiring, code, and the user's knowledge of the material. Toward this vision, we implemented ElectroTutor. The ElectroTutor interface consists of tutorial instructions, an integrated Arduino-like IDE for programming a microcontroller, and a panel with a series of interactive tests. At each step of the tutorial, the user must complete a set of tests before proceeding to the next step. Some tests are performed with a low-cost physical measurement tool consisting of a secondary Arduino, dynamically loaded with testing code. ElectroTutor includes a range of different tests across a taxonomy of test types presented in the paper. We will now demonstrate a selection of these test types from a tutorial we developed for building a light-sensitive alarm clock. Early in the tutorial, the user is prompted to test whether they can successfully upload starter code to the development board. This step of the tutorial instructs the user to paste some code into their loop function to activate a buzzer under certain conditions. To ensure they understand which statement turns the buzzer on, the user must complete a test by highlighting the correct line of code. The user is also prompted to test whether their code compiles, before they can advance to the next step. In the case of errors, a sanitized error message is shown in the test pane. In this step, the user is presented with a multiple-choice knowledge test. The user is instructed to connect an LED ring to the development board. To check that the user has wired in this component correctly, they are prompted to load preset code that tests the ring. To test dynamic behavior of the system being built, the user is instructed to insert test probes into the circuit. The test confirms that the voltage is as expected when the button is pressed. ElectroTutor also supports tests to measure frequency and continuity tests. On this step, the user checks to see that the value of a variable in their code matches the expected value when a light is shown on the sensor. To achieve this, the system automatically instruments the user's code to send runtime data from the development board back to the tutorial system. To evaluate ElectroTutor, we performed a between-subject study, comparing the full system with a baseline system without interactive tests. Participants used ElectroTutor to build the light-sensitive alarm clock pictured previously. Our study results are promising. The addition of interactive tests significantly reduced backtracking to previous steps to troubleshoot mistakes, and participants appreciated the features of the system.